Now that we've created PLE to supply the list of primes less than a given integer, the next step is to go through that list of primes and find their exponents. We will use PEXP to do this. So how does PEXP work? Let's use an example with a left argument of 2 and a right argument of 20. The left argument is the prime factor and the right argument is the number to be factored. The verb logarithm gives us the exponent for 2 with respect to 20. And since we're only interested in integer results, we'll use floor to ensure we have the next lowest integer for 2 log 20. Now, we don't just want the largest exponent of 2, we want all the multiples up to the largest. So we use this formula. We have seen the integers verb before, but this time it needs to be incremented using increment because integers returns 0 to n minus 1, and we want the values to be from 1 to n. The dyadic verb left returns the value of the left argument, which is 2 in our example. Similarly, the dyadic verb right returns the value of the right argument, which is 20. These are verbs often used to insert argument values into the flow of the J sentence. So the result of this code returns 2, 4, 8, 16 as the multiples of 2 less than 20. The next trick comes from this part of the program when we divide 20 by the powers of 2 that are less than 20 and round down to get 10, 5, 2, and 1. But what do these integers have to do with the exponents of 2 and 20? Well, let's look at the numbers up to 20 that have 2 as a factor. There are 10 that have 2 as a factor at least once. Those are the even numbers up to and including 20. Yeah, but what about 4? It has a second 2 in its factorization. That's where the 5 result in 10, 5, 2, 1 shows up, because the 5 integers, 4, 8, 12, 16, and 20, have a second factor of 2. A third factor of 2 occurs twice, once with 8 and once as a factor of 16. And the fourth occurrence of 2 as a factor in 16 only occurs once. So when we total up all the times that 2 shows up as a factor in the numbers up to 20, we just have to add 10 plus 5 plus 2 plus 1 to get 18. 2 shows up 18 times as a factor in all the numbers up to and including 20. We can do the same process for every prime factor less than 20 to get the exponents for the full factorization of factorial 20. Try out this J sentence for a few prime factors for the left argument and a few values of n for the right argument and see if it creates the exponents that you would expect.